Hello, dear students. Let's start our discussion today. In the previous class, we have seen the first chapter, some basics of first chapter, and also we have started our second chapter in the previous lecture, that was of inverse trigonometry. So, in that chapter, we have just recalled the previous trigonometric functions. That what are the sine function, cos function, tan, cot, and sec, cosec. And after that, we have seen the definitions of inverse trigonometric functions. That is the inverse of sine, cos, sec, cosec, sec, tan, cot. Okay. And also we have discussed their domains, range, their graphical representation, how the graphs were drawn. So if you have missed the lecture or you have any doubt in this, you can refer to the lecture which I taught in the previous class, and you can find it in the official GoAsk Academy website or their YouTube channel. So you can just go there and watch it. Okay. So we will start the discussion from where we have ended yesterday. So let's begin. Let's recall the domains and range of all the inverse function which I told you in the previous class. So, what is the domain of sine inverse function? That is -1 to 1 in the closed interval. Okay. And range is minus pi by 2 to pi by 2. These all we have covered. So, we can refer. Okay. Cos inverse has the domain -1 to 1 and range 0 to pi. Similarly, cosec inverse has the domain r -1 to 1 and minus pi by 2 to pi by 2 minus 0. Similarly, sec inverse has the domain r -1 to 1 open interval and 0 to pi minus pi by 2 is the range. Okay. Similarly, for tan inverse, domain is whole range numbers and range is minus pi by 2 to pi by 2 in the open interval. For cot inverse, you have the domain real number and range 0 to pi in the open interval. Okay. So let's move further and see that what are the next topics for us. Okay. So let's see some examples of these properties, what are the principal values of that trigonometric function and what are the domains of that. So we will see some example now. First question example is find the principal value of sine inverse 1 by root 2. Okay. So how to solve this question? Let's see. So if we have given any inverse function, we should take it equal to some variable. So here I have taken sine inverse 1 by root 2 equal to y. So we have to assume like this. Then we can if the sine inverse 1 by root 2 is y, we can write it like sine y is equal to 1 by root 2. Why? Because if we take inverse both sides, so sine y will come equal to 1 by root 2. Any inverse gives you angle only. Any trigonometry inverse will give you angle only. Okay, so this y is any angle. So it means that sine y must be equal to this only this value. So that is why we can write it like this only. Sine y equal to 1 by root 2. Okay. So we know that the range of the principal value branch of sine inverse is minus pi by 2 to pi by 2. So this is the range of sine inverse in the principal branch. We have already talked about this. Yeah. And sine pi by 4 is equal to what? 1 by root 2. So this already we know that in 11th class we have studied that sine pi by 4 is equal to 1 by root 2. So the principal value of sine inverse 1 by root 2 is pi by 4. Because pi by 4 is also coming inside this values, range of these values. You can see that pi by 4 is coming in between minus pi by 2 and pi by 2. So that is why we can take this value as the principal value of sine inverse 1 by root 2. This was a simple example. Answer is pi by 4. We let's move further and see what is the next example. Okay. So in the example second, we have to find the principal value of cot inverse 1 by root 3. So 1 by root 3, if you cot inverse minus 1 by root 3 is this. So if you like assume my cot inverse minus 1 by root 3 equal to y, then it will be obvious that cot y will be equal to minus 1 by root 3, and that is equal to minus of cot pi by 3, right? Because you know that minus of cot is like equal to minus of cot of pi by 3 will be equal to minus of 1 by root 3. Because minus sign is there, so cot pi by 3 value will be there, but minus sign is also there. And we can write it like cot pi minus pi by 3. We can write it like this because in the like it is coming in second quadrant, this angle, and in second quadrant you know that only sine is positive and cot and tan like are negative. So cot will be negative in this. So we can write negative of like value of cot like this only. So it will come cot 2 pi by 3, because when I will subtract pi like pi by 3 from pi, it will come cot pi 2 pi by 3. Okay. And we all also know that range of principal value branch of cot inverse is 0 to pi. So 0 to pi is the range of cot inverse. We have already seen that like in the open interval. And cot 2 pi by 3 is also equal to minus 1 by root 3. Okay, cot 2 pi by 3 also equal to minus 1 by root 3. We have already assumed that cot 2 pi by 3 is equal to minus 1 by root 3. So hence principal value of cot inverse minus 1 by root 3 is equal to what? 2 pi by 3. So this is our answer for this question. So we have seen that we don't have to just only see that what is the value of that angle, but we have to also observe that is the like your principal value is coming between the required range or domain also or not. Okay, so here we have seen that range of principal value branch of coordinates is 0 pi. So 2 pi by 3 must be in that interval only. So the answer should be in the range interval. Okay, we have to just keep in mind this also. Okay, so let's remove these drawings and see the next part. What is the next question or exercise 2.1 is there. So I will take some like example of this exercise. Let's try to solve some questions. Okay, so let's find out that which question I should take. Okay, I will solve like fourth part, tan inverse minus root 3. Okay, so what is the first step? We will assume y is equal to tan inverse minus root 3. So here, from here we will get like tan y is equal to minus of root 3. Okay, so how can I write like here? What angle should be there? So like tan y is equal to, and this is equal to like minus of tan pi by, if you remember that what is the value of at which angle the value of tan is like root 3. So it is equal to your like pi by 3. Okay, so tan minus tan pi by 3 is equal to what? Your minus root 3. Okay, and you can write it like this also, that tan pi minus pi by 3. Why? Because in the second quadrant I already told you tan and cot are negative, so I can write it like this also. Okay, and recall that what is the like range of your tan inverse. Range of tan inverse. What is the range of tan inverse? Just recall that also. So yeah, tan inverse has a like range equal to minus pi by 2 to pi by 2 in the open interval. Okay, so our answer should be in this interval only. Yeah, so how can I write this like this angle in this interval? 2 pi by 3 is in this like in this interval or not? No, that is not inside this interval. So I can write, if you see that A S T C. Okay, so in this quadrant, if I like take third quadrant, if I take third quadrant, like, so minus of like tan of minus theta is equal to tan of minus theta. So tan of minus pi by 3 will be equal to minus of tan pi by 3. So only like this I can get here. So that is why we have the domain answer of this principal value of this will be minus pi by 3. And minus pi by 3 is coming between pi by 2 and minus pi by 2. So minus pi by 2 and pi by 2 are like in between, the answer is in between these values. So I hope that you got this part, that how the answer is coming like this. Okay. So for this question, the answer is minus pi by 3. Minus pi by 3 is the answer. Okay. So I have told you that the final answer should be in the principal value of range of that function. So here, that is why it is coming minus pi by 3. Let's move to the next question and delete all the drawing. So yeah, we have to find the values of the following functions. Let's do one part, and remaining you can solve by yourself, because if I tell you one part, you can easily solve other parts also. So I will take the question 11 here. What is the value of tan inverse 1 plus cos inverse minus half plus sin inverse minus half? Okay. So let us assume that tan inverse 1 is equal to some x. Okay. So tan x should be equal to 1. So here, what is the value of x here? You have to calculate the value of x here. So x will be equal to pi by 4. Why? Because pi by 4 is also your coming between minus pi by 2 to pi by 2. Okay. And this is the principal value of your tan inverse. So for this part, you are getting pi by 4. I can write it like pi by 4 plus cos inverse minus 1 by 2. What is the value of cos inverse minus 1 by 2? Assume it like y. So y is equal to cos inverse minus 1 by 2. So from here you get cos y is equal to minus 1 by 2. Okay. Now when is the value of cos y is equal to minus 1 by 2? So let us see that in the second quadrant. Okay. In the second quadrant, if you have like at you know that cos y is minus of cos and pi by, this is like your 3. Okay. At cos pi by 3 you have the value of half. Okay, and minus sign is there. And also like you can write it like this. For second quadrant, cos of pi minus pi by 3, the value will be the same, because pi minus pi by 3 will give you the same value. But it is like coming second quadrant, so cos in second quadrant is negative. So this will give me the value minus half. So I can write it like this. So from here we are getting our value like cos 2 pi by 3. Okay. So y is coming equal to 2 pi by 3. So this part is also solved. I am getting here pi by 4 plus 2 pi by 3. And this 2 pi by 3 is also in the interval of range of cos inverse, principal range of cos inverse, because cos inverse has the range 0 to pi, and the answer is also coming in between this range. Okay. Yes. Yeah, just a second. Two parts I have just solved. Now I have to see the value of sine inverse by 1 by 2. So sine inverse 1 by 2 is, let's say z, it is equal to z. Okay. So sine z will be equal to what? Minus of 1 by 2. And I can write it like minus of sine of pi by 6. Because at sine pi by 6, the value is half, and also a negative sign is there. And if I see that where the sign is negative, so A, S, T, the sign is negative in third quadrant and second quadrant, second and third. Okay. So try to find out the value inside the like its range, principal range value, that is minus pi by 2 to pi by 2. Okay. So I will try to find out in this interval. So you can write it like this only. Minus of, like sine of minus theta is minus theta. Okay. So I can write it sine minus of pi by 6. And it is coming inside this interval also. So yes. Okay. I hope that you got it. So for this part, I am getting answer as minus pi by 6. Yeah. Just a second. Just a second. Just a second. Wait a minute. Yeah. So that is the value we are getting for z. So here I can write it like minus pi by 6. So after calculating the these all three terms, by adding these, we can get the value of your like 11th question. So let's solve this further. So I am getting like pi by 4 plus 2 pi by 3 minus of pi by 6. Okay. So now find out the value of all these terms and get the answer for your question. Okay. So from here, what is the LCM? LCM will be 4, 3 and 6. The LCM will be of like 24. Okay. Or 12. 12 is the LCM for that. So 12 LCM, and in the upper side you will get 3 pi plus 8 pi minus 2 pi. So what will be the final answer? 11 pi minus 2 pi, that is 9 pi by 12. Okay. And after simplifying, you will get 3 pi by 4. So for this question, you have the answer 3 pi by 4. That is the final answer. I hope that you got this question. We will now see like other examples of question. I hope that you got what I have told you. You can solve other parts by seeing this question, how I solved this. And if you have any doubts in like other questions, you can comment or you can ask for private sessions. I will solve for this. Okay. Let's move further and see what is the next question and what are like the other questions are like MCQs, and I hope that you can solve these all by yourself. So let's move to the next topic, and just a second, I'm coming. Okay. So we will see now some properties of inverse trigonometric function. In this section, we shall prove some important properties of the inverse trigonometric function. It may be mentioned here that these results are valid within the principal value branches of the corresponding inverse trigonometric functions and wherever they are defined. So there are some properties of trigonometric functions, like some formulas or properties, and these are already defined for the the principal value branches of these in trigonometric function, inverse trigonometric function. And yeah, some results may not be valid for all values of the domain of inverse trigonometric function. Like some uh, properties will be not valid for all the domain. Okay. In fact, they will be valid only for some values of x for which inverse trigonometric functions are defined. So they are like valid for some values where that inverse trigonometric functions are defined. Okay. We will not go into the details of these values of x in the domain. The discussion goes beyond the scope of the textbook. So we will see the basic only. We will not go in the detail. Let us recall that if y is equal to sine x, then x is equal to sine y. So this I already told you that how to take the values of angle of inverse trigonometric. So sine of sine inverse x is x belong to -1 to 1. So this is like a sine of sine inverse x. So here x should be belonging to -1 to 1. Okay, because here you can see that x is any angle here, and that has the domain should be equal to -1 to 1 here. And if sine inverse sine x is there, then x belongs to minus pi by 2 to pi by 2, because it is giving you an angle of in the final step. So that will give you your x value as minus pi by 2 to pi by 2. Okay. Same is true for other 5 inverse trigonometric function as well. We now prove some properties of inverse trigonometric function. So these are some properties. That is, first property is sine inverse of 1 by x is equal to cos inverse x, where x is greater than equal to 1 or x is less than equal to -1. Okay. So we will just now see the in some later part that how this formula has come and why the conditions are there. And the second formula is cos inverse x is equal to sec inverse x, where x is greater than equal to 1 or x is less than equal to -1. Okay. Let's move further. The third property is tan inverse 1 by x is equal to cot inverse x, where x is greater than 0. To prove the first result, we will put the cos inverse x equal to y. Okay, so cos inverse x should be put equal to y here. So x will be equal to what? Cosec x. Because first result is proved by cosec inverse. Sorry, I was telling cos. It was cosec inverse that is equal to y. So from there we will get x equal to cosec y. Okay. So therefore we will get 1 by x equal to sine y. So here we can see that for first for first property you just observe here, like this one, for this one formula. Okay. So we will start the result from where? From the assumption that where we have the cosec inverse x is equal to your y. Okay. Cosec inverse x is equal to y here. Okay. So x is equal to cosec y is the relation I am getting from here. If x is equal to cosec y, then what should be the your boundations on x? Here you can see here that x should be greater than like it is already mentioned in your previous, x is greater than equal to 1 or x is less than equal to -1. So here we can see that x should be greater than equal to 1 and x is less than equal to -1. Okay. Why is that so? Because you can see here that x is cosec y, and it means that x should be the range of cosec y, and range of cosec y is what? Like from -1 to 1 to infinity, that is minus infinity to 1, right? Minus infinity to -1 union 1 to infinity. That is the range. That is why the conditions are for x, that x should be less than equal to -1 and x should be greater than equal to 1. Okay. Because these points are like the range of your cosec x. Okay. Cosec x or cosec y. So that is why this is like written here also. See here, that should be clear to you. Okay. Okay, so I have told you just now that why the condition on x is given here in the question. So let's move further and see the calculation part of this, that how the formula has come. Yes. So after like x is equal to cosec y, we can like find out where what is sine y in this triangle, because cosec y is like, if you have triangle here, cosec y is x, cosec y is x here. Okay, it means that you have the like perpendicular here equal to what? This is your this is x and perpendicular is 1. Okay, that is why cosec y is coming equal to what? X. Okay, and from this triangle, what is the value of your sine y? Cosec y is x, so sine y equal to 1 by x. So that is why here it is written sine y is equal to 1 by x. Okay, so from there you can find out sine inverse 1 by x equal to y. After taking like inverse of both sides, so I have found out sine inverse x equal to y, or sine inverse 1 by x equal to cosec inverse x, because y is already, you have like substituted cosec inverse x only. So that is why from this and this point the proof is clear that sine inverse 1 by x is equal to cosec inverse x. Similarly, you can prove other formulas also of this second part and third part. You can try to solve that also, and try to analyze. If you have any doubts on this, we will help you out later. Okay, just mention or comment, I will help you. Now I should clear all these drawings and move to the next part. So second formula is also there in this chapter. So these types of formula are what? Like sine inverse minus x is equal to minus of sine inverse x for x belonging to minus 1 to 1. Okay, because x is there, the range of sine function. That is why this formula is like coming like this. Sine inverse minus x is equal to minus of sine inverse x. And tan inverse minus x is equal to minus of tan inverse x. Cosec inverse x minus x is equal to minus of cosec inverse x. Remember the like trigonometric function formulas. If you have like sine of minus x, that is equal to also minus of sine x, and tan of minus x is also equal to minus tan x, and cosec minus x is also equal to minus of cosec x. Similar to that pattern, it is also here in the inverse function. Okay, so what is the like proof of this? You can see the proof of this in like this example. So let sine inverse minus x is equal to y. That is minus x is equal to your minus x is equal to sine y. If you like take inverse both side, so that x is equal to minus of sine y. So x is coming equal to minus sine y. That is x equal to sine of minus y. So we can write it like sine of minus y also. And hence it is proved that sine inverse x is equal to minus y. That is equal to minus of sine inverse minus x. Okay. So from there we will get sine inverse of minus x equal to minus of sine inverse x. Yeah, I hope that you got this formula and get proof. The proof is not important for you, but formulas like you have to remember. Let's move further and see what the next type of formulas. So the next type of formula is cos inverse x minus x is equal to pi minus cos inverse x, where x belong to minus 1 to 1. Okay. Sec inverse minus x is equal to pi minus sec inverse x, where x mod of x is greater than equal to 1. Cot inverse minus of x is equal to pi minus cot inverse x, that is x belong to like real numbers. So how these formulas have come, let's find out. So let you like assume cos inverse minus of x. We will see the first part of this. So cos inverse minus of x is equal to y. So this implies that minus of x is coming out to be equal to what? Cos y. Okay. Just take inverse both sides, you will get this. So that x is equal to minus of cos y. So how this come? I have taken just minus sign in the right hand side of cos multiplied by both sides. I have multiplied by minus 1. Okay. So this is equal to minus of cos y. We can write it like the cos of pi minus y, because in the second quadrant cos is negative. So I can write minus of cos y equal to cos pi minus y. So therefore we can also write cos inverse is equal to pi minus y. And that is why, because you can see here that cos inverse x is equal to pi minus y. If you take like inverse both sides, so cos inverse x will be equal to pi minus y here. So that is equal to pi minus of cos inverse minus x. Because y value is already, we have seen that it is equal to cos inverse minus of x. So I have substituted that value here, and I will get here from that cos inverse minus of x is equal to pi minus cos inverse of x. Because cos inverse minus of x is what? Your cos inverse x only. So that is why it is coming equal to what? If you see that from here, see here, you are getting cos inverse of like x is equal to pi minus cos inverse minus of x. After taking like pi this side, or you can take cos inverse minus x this side. So cos inverse minus of x will be what? Pi minus cos inverse x. Just take cos inverse x in right hand side and cos inverse minus x in left hand side. So you will get the result. So after that, that is the formula you are just wanted, and you get this. Okay. This is the proof of this part. I hope that you can do other parts also, like sec inverse minus x and cot inverse minus x. And the foundations on x is here. Why these are foundations? Because x should be the like belonging to the range of cos x. Okay, that should be here. That this should belong range of cos x, because x is here only what? Your like values of cos x, like cos of any angle is like this x are. So these should be minus 1 to 1. Similarly for sec inverse minus x, this should be like range of what? Sec x. Sec x for your range, like mod x is greater than 1. Okay, so that will give you what? Similar result, that x belongs to minus infinity to minus 1 union 1 to infinity. Similar to that, this is written like this: mod x is greater than equal to 1. Similarly, cot inverse x, their range is like real number, so that is why it is written x belonging to real number. So I hope that you got why the x foundations are there. So let's move to the further part and see the next type of questions here, or properties like formulas. What are the next formulas? The next formula is like sine inverse x plus cos inverse x is equal to pi by 2. That's a very important formula. These three formulas are very important. Like you have already seen some identities in trigonometric functions, that sine square x plus cos square x is equal to 1. Similar to that, there are three formulas that is in the inverse trigonometric functions that you must remember that. So sine inverse x plus cos inverse x should be equal to pi by 2, where x belongs to minus 1 to 1. Why this x foundation is there? Because x is range of sine and cos. That is why this should be minus 1 to 1. Okay. And in similar to that, tan inverse x plus cot inverse x is also equal to pi by 2. And here x belongs to range of tan and cos. Okay. And here also cosec inverse x plus sec inverse x is equal to pi by 2, where x is the range of second cosec. So that is equal to mod x greater than equal to 1. Okay. We will see the proof of one function, and rest you can find out by yourself. So let's assume that sine inverse x is equal to some y. Okay. So then x will be equal to what? Sine of y. And that will be equal to what? Cos of pi by 2 minus y. this formula you already know that this is your what? This is your uh, we have seen that this is your in 11th class. You have uh, you have seen it like formulas for composite like angles pi by 2 minus y. Okay, that sine pi by 2 minus y. Okay, complement angle formulas are this. Like if you have this, then it is equal to cos of y. Similar to that, if you have x is equal to sine y, then I can apply here complement angle formula, that is equal to cos pi by 2 minus y. It is equal to cos pi by 2 minus y. So I have written like this. So from there, we will find out x. So cos inverse x is equal to pi by 2 minus y. How this has come? Because x is equal to cos pi by 2 minus y. I have taken cos here, this side. So cos inverse x will be equal to pi by 2 minus y. And similar to that, I can write it like pi by 2 minus y is what? Y is here sine inverse x only. So I can write it like sine inverse x. After taking sine inverse x to this side, I can get cos inverse x plus sine inverse x equal to pi by 2. That is the important formula for you, and it is like identity for inverse function. Okay. Similar to this proof, you can prove other two formulas also. So I leave it for you, and you should do this. Okay. Let's move further and see what is the next formula or what is the next topic we should learn now. So yeah, let's move. I should clear these drawings first. So the next formula is also very important for you. That is the relation between tan of like two functions or two like values. So let's see what is the formulas and find out how it is like calculated. So here tan inverse x plus tan inverse y should be equal to tan inverse x plus y upon 1 minus xy, where xy should be less than 1. Xy should be less than 1 here. So we will see that why this condition is also applied here and how this formula has came. So let's find out and let's see that like what is the result of this. Okay. Yeah. Just a second. Yes. Okay. So let's see the proof of this formulas, that the tan inverse x, that is very important for you, that equal that formula tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. Xy should be less than 1. So why this xy should be less than 1 condition is given here? So why this is given? Because if you take tan inverse x plus y upon 1 minus xy, and xy here is greater than 1, okay, or equal to 1. For equal to 1, it is not defined here. So denominator should not be equal to 0. Denominator never equal to 0. This you know in math, that denominator can never be equal to 0. That is why one condition is not fulfilled here. And also xy should be greater than like less than here it is given that xy less than 1. Okay. So xy less than 1 should be followed here. If xy is greater than 1 here, so what happened? You will get tan inverse x plus y upon 1. Xy is also here what? Greater than 1 here. So you will get in the, like if I take 3 value here, so it will be negative in the below, like in the denominator. So it will give you tan inverse of minus of theta. Okay. And it is not equal to tan inverse of theta. So if you take xy greater than 1, it will your change your final answer. because tan inverse minus theta is coming here, not tan inverse theta is coming here. So that is why xy should be less than 1 here. Similar is the reason for this, xy is greater than minus 1, because if you take the xy value less than minus 1, so it the negative, like this term will become negative for you, and tan inverse of minus theta will be given here. Like tan inverse of minus theta will come here, not tan inverse theta, final answer will come here. Okay. So that is why we have taken here what? We have taken here this condition from xy. So let's find out that how these formulas have come. We will see the like derivation of this. Okay. So assume that tan inverse x is theta here. Tan inverse x is theta. Let's say that tan inverse x is theta and tan inverse y is phi. So I have taken two angles. Tan inverse x is equal to theta. Tan inverse y is equal to phi. Okay. So from there we will get x is equal to tan theta and y is equal to tan phi. That is obvious. We can just find out that also. So tan theta plus phi is what? You know the formula of tan a plus b. In the like 11th class you have studied already that tan a plus b is what? Tan a plus tan b upon 1 minus tan a into tan b. So that formula already you have like learned, and I hope that you remembered that formula. So that is similar to this formula. So here tan theta plus phi, I have applied this formula only. So this will be the result of that. Now you substitute the tan theta value, that is here x, and tan phi value, that is equal to y here. You will get x plus y upon 1 minus xy. That is very simple to like prove, and this will give you theta plus phi is equal to what? Theta plus phi is coming out to be equal to tan inverse of x plus y upon 1 minus xy. Okay, so we can easily prove that tan inverse x plus tan inverse y, because this is the only theta plus phi is only tan inverse x and tan inverse y. So that is equal to tan inverse x plus y upon 1 minus xy. So I hope that you got the like derivation also, that how is this has come. So similar to that, you can prove this second formula also. I hope that you can all do all these formulas derivation similar to what I have told you in the previous topics. Okay, let's move to further parts and clear these drawings. So sixth formula, like sixth type is this is also for like tan inverse function, and this is conversion of tan inverse to sine inverse and cos inverse. So that is also very easy to prove, and here also there are some conditions on your x and y. X only, sorry, here x is only the term, so there are some conditions on x here. So here you can see that mod x is less than equal to 1. So why this condition is like coming here, you can clearly observe that because mod x should be less than equal to 1 is fulfilled here. Just a second. Yeah, because if your mod x is less than equal to 1 is not fulfilled here, this term will again become minus of whole term, and this will give the deviate with the answer. It will give another answer, because sine inverse of theta, sine inverse of any value x, like x or minus of x, it will give you value minus of sine inverse x. So that is not the answer we are getting here. I have to get the answer sine inverse of x only. Okay, so like you should not have these formulas should not should not deviate from the original formula. Similar to that formula, you have to tan inverse x equal to cos inverse 1 minus x square upon x 1 plus x square. So that is the condition for that, x should be greater than equal to 0. Okay, x here should be greater than equal to 0 only. If x is less than equal to 0, then what happens? Okay, x is less than equal to 0, then this term will become again negative and your answer will deviate. So all these restrictions are for your not changing the whatever inside the tan inverse or cos inverse functions. or sine inverse. Let's see the derivation of first one formula, and other you can do by yourself. Tan inverse x is equal to y. We can like take here tan inverse x equal to y, then x is equal to tan y. Okay, so x will be equal to tan y here. Now sine inverse 2x by 1 plus x square is equal to sine inverse 2 tan y upon 1 plus tan square y. So if you like see this formula, sine inverse 2x plus 1 upon 1 plus x square. Okay, that will be equal to what? Because x value is already you have known tan y. So it will be coming like that, sine inverse 2 tan y upon 1 plus tan square y. Okay, and this is the formula of sine 2y. How this is sine 2y? If you remember, like in class 11th, sine just a second, tan, like sine 2y formula is equal to your 2 sine theta cos theta. Okay, this formula I think you have just remembered this. Okay, you can write it like 2 sine theta upon sec theta, because cos theta is 1 by sec theta. Now just to multiply it with what? You can multiply it with sec theta, both numerator and denominator. Okay, so it will come 2 sine theta into 1 by cos theta upon sec square theta. Okay, and now substitute 2 tan theta. Sine theta by cos theta is tan theta upon sec square theta is what? 1 plus tan square theta. So this is the proof of this formula. If you don't remember this formula, so you can prove it also by yourself. So that is why it is coming 2 tan theta upon 1 plus tan square theta is equal to sine of 2y. Okay, sine of 2y is there. So sine inverse of sine of 2y is what? Sine will cancel out, sine or sine and sine inverse. So it will come like equal to 2y, and substitute y value is what? Tan inverse x. So here you will get 2 tan inverse x, your answer. This is the proof of this formula. I hope that you got it and you can prove others by yourself. Let's move further, and I will share this drawing. Yes. So till now, I hope that you all got what I have taught you today. And I think that today, like this lecture should be end here, because I have already taken like maximum time lecture today, and it was enough for today also. So we will see like other examples and questions of these all formulas and try to solve them. Also, we will proceed to the next topic and next chapter also in the further lectures. And I am basically covering here CBSE pattern, your CBSE pattern exams or inter sessions like board exams. If you like are interested for JEE courses, so we will like cover that also in the later part. So I hope that you like the session today. If you have any kind of doubt or any kind of questions, you can post here or you can ask in the comment box like that. And if you want any like private sessions or one-to-one sessions, you can also tell us and we will arrange for you. Okay. So thank you and have a great day for today. Okay.